This is the first of the videos we're going to do that covers one of the various sorting algorithms that we're going to discuss. In this video, we're going to take our time and you'll see how these algorithms work. In subsequent videos, we may go a little bit of a faster clip, but for now, let's just go through it one step at a time, make sure we understand everything. First of all, the name of this sorting algorithm is called an insertion sort. And it's basically akin to how you would sort a hand of cards. You have cards that are face down on the table and you'd pick one up. And then you pick the next one up and you would decide which order they went in. You'd find the place where that particular card belongs and insert it there. Then you'd pick up another card and you'd find where it belongs and insert it there. And then so on and so forth. So the end goal would be a sorted hand of cards. Now, it's a good parallel because what we're going to do with this algorithm is we're going to sort a collection of numbers from lowest to highest, which is often what you'll be doing when you pick up cards. Now, it's just an example. It's not just used for cards. What we're going to illustrate here is one approach among many to take a collection of numbers and sort them lowest to highest. This particular approach uses an algorithm called an insertion sort algorithm. Let's dive into how it works. I want to show you what we're looking at here. This is code, computer code, and this represents how to do what you would have done manually by picking up cards and sorting them in your hand. We make use here of a few different things that we haven't covered before, so I want to define a couple of terms, okay? First of all, this right here, this is int, that means integer. It is a data type called integer, which is whole numbers. 1, -5, 264,000, so on and so forth. 5.2 would not be an integer. 5.2 would be a decimal because it includes fractions of numbers. Okay, great. So let's dive into this and do this one step at a time, just like a computer would. Along the way, we're going to keep track of all the different variables we make use of in our code, so you'll be doing what the computer would be doing. Of course, it'll do it a lot faster than we're going to. First thing we look at is this instruction right here. This instruction declares an array of type integer. In other words, it sets aside locations in memory for a list of integers, whole numbers, that all are grouped together in a data structure called an array. They have an exact order. That order is indicated by what are called indices or indexes. And you may recall that typically they go from 0, 1, 2, 3, 4, so on and so forth. In other words, it's a zero-based counting system. Now, I just made these red marks here just for easy readability as we go through the code. They wouldn't be part of the actual computer code. All right, so here's this first line again. And what it does is it declares a variable, which is called nums. This variable is an array of integers, and it even initializes the values in that array to this number series you see here, 52176. This is, in fact, the collection of numbers we're going to sort from lowest to highest. Now, I want to cover something that comes up occasionally when we go over this. You've already sorted them in your mind. I know you have. You look at that and you go, Eric, it's 12576. How hard was that? You need to be able to get the computer to do it. What if this collection were 500,000 numbers long? Don't know you'd be able to do it that quickly. So, the chief value in a computer, in terms of data processing, is that it can do things that would take humans hundreds or thousands or millions of times the length of time and do them in just seconds. Good, so let's see how it would sort this. Here's the next instruction right here. This is what the computer would be executing. Now this looks complicated, and at first glance it is. All this line of code is doing is setting up a loop, a section of code that we're going to repeat a certain number of times. So, a bit of how this works. This curly bracket here and this curly bracket here are the beginning and ending of the loop. And this line right here defines some parameters that tell the computer how often to do whatever instructions are in between the beginning and ending bracket, or opening and closing bracket, they call those. It tells how often to do it, when to stop, other instructions along the way. Let's break that down. The first little chunk right here declares another integer we're going to call counter and initializes its value to 0. That'll be used here because this next part of this for instruction is, okay, how do I know whether or not I'm going to execute the code inside these brackets? What's the conditional statement that we're going to apply? The conditional statement here is if the value of this variable called counter is less than the length of our array, then we'll do all the instructions. Let's look at that in a little more detail. We're making use of a nice little shortcut here where we have something we can tell about this array, which is how long is it, how many elements are in that array. In our case, we know from counting them that it happens to be 5. Notice we're subtracting 1 from that. So what we're really saying here is, as long as the value of this integer called counter is less than the length minus 1, in other words, 4, then we're going to do everything inside this little chunk, this opening curly bracket and closing curly bracket. Okay, good. Last thing is, every time we're done executing all these instructions inside the brackets, what do? We take this variable counter and we add 1 to it. Recall from an earlier video that plus plus is just shorthand for add 1 to whatever the current value is. So right here we've defined in one line everything we need to know about a loop that we're going to ask the computer to execute based on certain conditions. We have a counter variable initialized. We have the conditional statement that tells whether or not to actually execute the code. And we have an instruction on what to do every time you get done executing that code. Well, what's inside the code? Another loop. Look at that, it's another loop. And it has these curly brackets. So these are united as these are united. It means we're going to be doing this loop here, which is called an inner loop, probably many, many, many times. But let's take a look. It's the same thing. Here we have a for loop. This one has a different integer we're going to use. It happens to be set to whatever the value of counter is plus 1. Exactly why will become obvious as we go through the algorithm. For now, just recognize that when the computer hits this section of code, it's going to create an integer called index, and it's going to initialize the value of that integer to whatever the current value of counter is plus 1. Good. Now here's the conditional. As long as this integer we've just defined and initialized, called index, is greater than 0, then we're going to do everything in between these two curly brackets. And finally, what are we going to do every single time we get done executing that code? This is shorthand for subtract 1, minus minus. We're going to subtract 1 for whatever this is. Both this outer loop and this inner loop are designed to traverse back and forth through this data structure. If you recall during our video about abstract data types, the form of the data, and some descriptions of their behavior, one of the behaviors that you can describe about a data structure is traversing along that data structure. We're going to traverse through this data structure several times, and you'll see it in action. Good. Now, let's actually execute the code, because we've gotten to the inner loop. We've defined an outer loop, an inner loop, and then there's some code to be executed in that inner loop. And we're just going to do this, and you'll see what happens to our array and how we put it in order from lowest to highest. Down below here, I've listed out the variables that we have in our code, and we're going to keep track of their value as we go along. First thing, we hit this declaration of the array called nums, which I've written down here, and it's initialized to these values: 5, 2, 1, 7, and 6. Good. So right now, in the computer, in memory, these values are stored with the additional data of what order are they in. So there's our nums variable, this array of integers. All right, so now we set up a loop. We set up counter equal to 0. Let's write down counter is right now equal to 0. That's in memory in the computer right now. It's keeping track of it. And then counter is we got to check, is counter less than the length minus 1? Well, counter is equal to 0. That's certainly less than 5 minus 1, which is 4. Okay, good. So we are going to execute everything inside these brackets. Good. So the first thing we do when we get inside the bracket is we have another for loop. We set up a variable called index, and we set it equal to, we initialize it to the value of counter plus 1. Counter is equal to 0 right now. Add 1, and index is now equal to 1. Great. Now let's check this the condition. The conditional statement on this loop is we're going to do everything inside these brackets as long as index is greater than 0. Well, look, index is 1. That's greater than 0, so we are going to do everything inside these curly brackets. Now we get to the decision point about where we insert our values. Check this out. First thing is an if statement. If this is true, it's a conditional statement. If this whole thing right here evaluates to true, then we're going to do what's inside here. Well, let's look at it. I'm going to take this one little step at a time. This first chunk right here, nums, open bracket, index -1, close bracket. What we're trying to find out is what is the value of a certain element in that array. Remember, the elements in this array have indices, 0, 1, 2, 3, and 4. In other words, what position are they at inside the array? So what this little chunk right here represents is what's the value of the element in this array called nums that is at position index -1. Well, index right now is equal to 1. 1 minus 1 is 0. What's the value of the element in the array nums at position 0? It's 5. So 5, is it greater than this? Well, what's this? This is what's the value of the element in the array nums at position index. Index is equal to 1. So the value in the array nums of the element at position 1, its value is 2. You can see it right there. So this is the comparison. Is 5 greater than 2? Yeah, it is. And you've already done this in your head. You go, man, we got to swap these things. We got to switch them. That's what's going to happen right here. This is where the swap happens. So we do this by making use of a temporary storage area for one of the values. We create a variable, an integer, called temp. It's right down here. I'm going to list its value in a moment when we figure out the value. We initialize its value to whatever the value is of the element in the array nums that's at position index -1. Well, index is 1, so 1 minus 1 is 0. What is the value of the element in the array nums at position 0? It's 5. We already know that. So we initialize this integer temp to be equal to 5. It's basically holding that value that's in the very first place. Why? Because look what we do right here. We are now going to set the value of the element in the array at position index -1, 1 minus 1, which is 0. So the value of the element at position 0, which is this one right here, our 5, we're going to make it equal to the value of the element in the array at position 1. That's a 2. The value of the element in the array nums at position 1, the value is 2. So we make this a 2. If you need to back up and look at that again, please do. Look at what we've done. We have overwritten the value of one of the elements in our array. And we lost our 5. We now have an array that's equal to 2, 2, 1, 7, 6. That is not sorted lowest to highest, but we're not done. We stored that 5 somewhere. We stored it in this integer called temp. It's a temporary holding area. So now we make the element in the array nums position is 1 equal to whatever the value is. So here is element 1. Its value, we're going to make it equal to 5 because that's what's stored in temp right here. Look what we've done. We've actually swapped these first two so that they are in ascending order. And we've now reached the end of this curly bracket. And so we get to roll back up out of this. And you'll see how and why. So this is the if statement. We completed everything in the if statement. We are inside this inner loop defined by the for. Every time we get done executing that loop, which we just did, we have to -1 from index. That, by the way, is called decrement. It means to -1 or to lower in value. So we're going to take index and we're going to reduce it by 1. Index is now going to become minus 1. 1 minus 1 is 0. Now we need to check, are we going to even execute this for loop? And that's the conditional statement right here. Is index greater than 0? No, it's not. So we're done executing this for loop. But we have now fully executed everything inside this outer loop. There's nothing left there's no more instructions. So what do? We do that. We increment or add 1 to the variable counter. Counter has been equal to 0, but we add 1 to it, and now counter is equal to 1. And then, because it was all involved in the definition of this loop, we check our conditional statement. Is the value of counter less than 4? Yes, it is. It's equal to 1. So we are, in fact, going to do everything inside here again. Let's do it. We get to this loop. We declare a loop, but we do it with the current values of all of our variables. We're going to set index equal to the current value of counter plus 1. The current value of counter is 1, so index becomes 2. We are going to check, should we execute this loop? Well, is index greater than 0? Yeah, index is 2, so we should execute this loop. And now we go down inside the loop. And we're going to check. Let's erase some of this little sketch here. Here's a conditional, the if. Are we even going to execute what's followed by the if statement inside these brackets? Well, let's check. We're comparing values. We're comparing this value to this value. Value of the element in nums at position 2 minus 1, or 1. The value in 1 is now 5. There's the value, 5. Is that greater than this? Well, what's this? That is the value of the element in nums at position 2. Oh, look at that. It's a 1. Is 5 greater than 1? Holy moly, it is. All right. Then we're going to execute this. What we're going to do is we're going to set that variable temp equal to the value of the element in the array nums at this position, index minus 1. Index is now equal to 2. 2 minus 1 is 1. What is the value of nums at position 1? It's 5. So temp becomes equal to 5. Oh, look at that. All right, good. Now, we're going to do a swap. We're going to say nums, the array element at position 2 minus 1 is 1. So that can become equal to the value in nums at position 2. So the value in 1, which is right here, it's a 5, we're going to make equal to the value in 2. There it is. We made the value at position 1 equal to the value in position 2. It's a 1. But then we don't want to lose our 5 like we did before, we almost did before. So now we set the value of the element in the array nums at position 2 equal to that temporary number we stored, which is a 5. So now we make this a 5. Look at that. We've flipped these two, but we're still not in ascending order. Let's see how the algorithm takes care of that. We've actually executed everything on this if statement. And so now we pop out and we've completed this for loop. What do we do when we're done with the for loop? We do this. We decrement or minus 1 from index. Index was 2. Let's make it equal to 1. Now we check our conditional. Is index greater than 0? Yeah, it's 1. We just set that. So we are going to execute this. What do we do in here? Well, we check our conditional because it's an if statement. Let's compare these two numbers. Index right now is equal to 1. So what's the value of the element of the array nums at position 0? It's 2. Is that greater than the value at position 1? And the value at position 1 is 1. 2 is definitely greater than 1, so we are going to do this code in here, the swap code. And we do this all over again. Let's take this variable temp and set it equal to the value at position 1 minus 1, which is 0. So we're going to take this temp and set it equal to 2. That's our holder. We're holding that value 2. Why? Because now we're going to do this overwriting option. or overwriting instruction. We're going to take whatever's in position 1 minus 1 is 0, so position 0, that's a 2, and we're going to make it equal to whatever's in position 1. Well, 1 is there, so we make this a 1. And then we do this. We take our temporary storage data and we put it at position index of 1, num position 1. We put the 2 there. Look at that. We've now sorted in ascending order the first 3 elements of this array, 1, 2, 5. It was 5, 2, 1. Good. We're not done yet though, because look what happened. We are now at the end of this inner for loop. What do you do when you get to the end of the loop? You do that instruction. You decrement index. Index was 1. We minus 1 and make it a 0. And now we check the conditional. We're only going to do this for loop as long as this is met. Is index greater than 0? No, it's equal to 0. So we are done with this loop. We don't do it anymore. And now there's no more instructions. So now we're at the end of this outer loop. What do we do when we hit the end of this outer loop? We do that. We increment counter. We add 1 to it. What's counter equal to? 1. Oh, add 1 to it, and now it's equal to 2. Good. Now we check our conditional. The conditional is counter, currently equal to 2, less than 4? Yes, 2 is less than 4. So we get to do this whole loop again. The first thing in this loop is setting up another loop. Let's do it. Index. We're going to use this in our loop. It's equal to counter plus 1. Counter right now is equal to 2, so 2 plus 1 is 3, so index becomes equal to 3. Excellent. All right, good. And you're starting to see a pattern here. Index is telling us which position in this collection are we about to check. Good. So we have an if to check here, because now we're inside. Oh, we check, are we going to do this loop? Yeah. We've set index equal to 3. 3 is definitely greater than 0, so we are going to do what's inside this loop, these 2 brackets. First thing is a conditional statement. We check these 2 values. Let's erase what we have here. All right. So what we have here is, first, what's the value of the element in the array at position 3 minus 1, position 2, and position 2 is 5. All right. Is 5 greater than whatever this is? Well, what's this? The element in the array at position 3, 7. Is 5 greater than 7? No, it's not. Oh, wow. We're not even going to do this code, are we? No, because we don't meet this if. 5 is not greater than 7. Not in this universe, at least. So we jump over this if, and we have executed the for loop. So what do you do when you're done executing it? You do that. Subtract 1 from index. Index is 3. We're going to subtract 1 and make it 2. Okay, good. Awesome. All right. Now jump back in. Why? Because index is greater than 0. 2 is greater than 0, so we check the conditional. We are going to do this. We jump back in, and it's this if statement. Well, now we're saying, what about comparing the value at 2 minus 1 is 1, position 1 is a 2. Is that greater than whatever is at position, let's see, 2, 5? Is 2 greater than 5? Nope, sorry, it's not. So again, we're not going to execute this if statement, all this code inside it. And we've reached the end of another time through this loop. What do? You decrement index. Index, instead of becoming 2, you subtract 1 from it, it becomes 1. All right, good. Now, check the conditional. Are we going to do this loop? Index greater than 0? Well, it's 1. 1 is greater than 0. So yeah, we are going to do the loop. And now we hit this again. And here we have compare 2 different numbers. So index is currently equal to 1. So 1 minus 1 is 0. What is the value at position 0? It's a 1. Is 1 greater than whatever this is? Well, this is the value at position 1, which is 2. Is 1 greater than 2? No. So again, we do not execute this swap. So now we've reached the end of another iteration, another time through the loop. What do? You do that. You decrement index. You subtract 1. Well, index was 1. Now we subtract 1 from it, and we get 0. And now we check our conditional. We're going to do this for loop if index is greater than 0. Well, no, it's equal to 0. That's not greater than, so we don't do this. And because there's no other instructions to execute, now we're going to do whatever we do at the end of this outer loop, which is increment the counter. Counter, add 1. It was 2. It becomes 3. All right, now check our conditional. We're only going to do this outer loop, this defined by these brackets and that for instruction, if counter, currently equal to 3, is less than 4. 3 is less than 4, so we are going to do it. All right, let's dive into it. Here's another definition for a loop, for loop. We set up index and we make it equal to counter, currently equal to 3, plus 1. So index becomes 4, which makes sense because we're about to handle that element in the array, number 4. Okay, good. So we have set up index. We have a comparison to make. Is index greater than 0? It certainly is. It's 4. All right, good. Let's pop inside this loop. First thing we do is check a conditional. And we've seen this over and over again. Index is now equal to 4. 4 minus 1 is 3. What's the value of the array at position 3? It is 7. Compared to it over here, what's the value of the array at position 4? It's 6. Is 7 greater than 6? Yes. Okay, good. We're going to execute this code inside these brackets under the if statement. First thing we do is set up this integer variable called temp, and we make it equal to whatever's at the array, position 4 minus 1 is 3. Position 3 is a 7, so temp becomes 7. It's been sitting there 2 the whole time, but it didn't matter. We didn't use it for anything. Now it's 7. Great, so we set up this variable. Now let's check, let's do this swap. The element in the array at position 4 minus 1, 3, okay, 3, we're going to make that equal to whatever's at position 4. Position 4 is 6, so we're going to make this 6. And then we take our temp data back. We make the element in the array at position 4 equal to the value we stored for temp, which is 7. Now, we're at a very critical point in terms of computer science and learning to code. You are right now looking at this collection of numbers, and you know it's sorted in ascending order. Does the computer know? You can look at it and tell. How are you telling? Because it's immediately obvious. You can look at each one and know that they are in ascending order. The computer can't do that. It has to be given very exact, precise instructions that under every single possible condition of the data, we can guarantee that the end result will be the purpose achieved. In this case, sorting numbers low to high. This algorithm is built to ensure that no matter what, we end up with a collection of numbers that's sorted from lowest to highest. So we're about to go through all these checks, and we're not going to end up changing anything about the data in this array because, as you can tell from looking at it, it's already sorted. But these next steps through, what's actually happening is the computer is verifying beyond a shadow of a doubt that all of the conditions required here are met, and only when it gets all the way through it does the computer, quote unquote, know that it's sorted from lowest to highest. So let's continue. The last thing we did was we set the element of the array at position 4 equal to the value we had in this integer variable called temp, which happened to be 7. We've done that. Now we're done executing the if statement, and that leaves us at the end of this inner loop, this for loop. So what do? We decrement index. Index goes from 4 to 3. Then we check the conditional. Is index 3 greater than 0? Yeah, it is. Let's execute. So let's check the conditional. If the element at 3 minus 1, 2, which is 5 right there, is greater than the element at the array position 3, 6. Oh, it's not greater than, so we don't do this. But we reach the end, and we have to decrement the index. Index now becomes 3 minus 1 is 2. And then we check the conditional. Is 2 greater than 0? It certainly is, so we're going to do this. And we get in here and we compare with the different values. The element of the array at position 2 minus 1 is 1, 2. So there's the value, 2. Is it greater than the element at position 2, which is 5? No, 2 is not greater than 5. So we don't execute the code inside this if statement. All right, good, fine. We've reached the end of this inner loop. We actually decrement index minus 1 from 2 down to 1, we check the conditional. Is index currently equal to 1 greater than 0? Yes, 1 is greater than 0, so we are going to in fact execute this loop. First thing in the loop, we check this conditional if statement, and it compares the value in the array at position 1 minus 1 is 0, that's a 1 right there, to the element in the array at position 1, which is a 2. Is 1 greater than 2? No. So we don't execute this if statement. We've reached the end of this for loop. So the first thing you do is you decrement index. So it goes from 1 down to 0. Check your conditional. We're only going to do this loop if index, currently equal to 0, is greater than 0. Oh, it's not. So we don't execute this anymore. We're done with that loop. And now we've actually reached the end of this outer loop because there's no more instructions to run. What do? You increment counter. Counter has been 3. We make it equal to 4. Check our conditional. Is counter, currently equal to 4, less than 4? No, 4 is not less than 4. So we're done with this loop. We're done with the whole program. And we have a collection of elements, integer elements, that's been sorted from lowest to highest. Now, back to the name insertion sort. You can go back through this if you want, and I do recommend it. And you'll notice that as you approach or as you grab a hold of each new number, each new item in the array, what you're actually doing is going earlier and finding out where do I insert this element in order to have a properly asserted array. And that's why it's called insertion sort. As you see other sorts come along, you'll see different names, and they will be indicative of what you do with the data. And here's the important thing. We're going to get right back to why we even have these. This is just one illustration of how you could implement a desired behavior called sort ascending. All the other videos we're going to see and all these different sorting algorithms, they're all going to end up with the same thing. You're going to get so familiar with this collection of 5 numbers, you're probably not going to see it anymore. And at the end of it, every algorithm will show a final product of 1, 2, 5, 6, 7, a sorted from low to high collection of numbers. But each one will do it in a different manner. And this is all to illustrate, as I said earlier, that 1, there's lots of ways to skin a cat. There's so many different ways to solve the same problem. But 2, they all have their trade-offs, their benefits, and their disadvantages. And one of the things you'll learn as you go along is when do I use which tool? It's a bit beyond the scope of this course to be able to analyze the exact optimum algorithm to use, but you'll know they're there and some of the ways they work. Along the way, you're also going to get very familiar with using these loops. And this is a key aspect of computer programming because, again, computers themselves, they are data processing tools. And when you're processing collections of data, you make use of traversing all the way through that data and doing things to it over and over and over again. It's a key element of what you can do as a programmer. That's our first video on sorting algorithms covering insertion sort.